SpaceX's vision is to make humanity a multi-planetary species, a dream that has captured the imagination of millions around the world. At the heart of this ambitious plan is the Starship, a revolutionary spacecraft designed to carry astronauts back to the moon and beyond. NASA has selected a specially modified version of the Starship for its Artemis missions, with the goal of landing the first woman and the first person of color on the lunar surface, marking a historic milestone in space exploration. However, there's a significant challenge that needs to be addressed. Starship requires an enormous amount of fuel to make the journey to the moon and back. The current plan involves launching a lunar lander Starship into orbit, followed by sending up several tanker Starships to refuel it while it's in space. This in-orbit refueling process is akin to a floating gas station, but it's a feat that has never been attempted on such a large scale before. Each tanker launch and subsequent docking introduces additional risks. If even one mission fails, it could result in significant delays or even the complete loss of the mission. Estimates suggest that anywhere from 4 to a dozen tanker flights might be necessary for a single lunar landing mission. Coordinating all these launches is a massive logistical challenge, requiring precise timing and flawless execution. This complexity has led some engineers to question whether there might be a simpler, more efficient way to achieve the same goal. Perhaps the answer lies in revisiting some of the bold ideas from the early days of space exploration, when innovation was driven by necessity and imagination. Sometimes the best solutions come from the past, offering insights that can help us overcome the challenges of today and pave the way for the future. In the 1960s, NASA engineers dreamed up the Nova rocket, an even bigger beast than Saturn V. At a time when the world was captivated by the space race, these visionaries were already thinking beyond the limits of what seemed possible. The Nova rocket was imagined as the ultimate launch vehicle, a machine that would dwarf anything built before it and push the boundaries of human exploration. Nova was designed for direct ascent, launch from Earth, land on the moon, no orbital rendezvous needed. This approach would have eliminated the need for complex maneuvers in lunar orbit, making the mission more straightforward and, in theory, less risky. The rocket would carry everything needed for the journey in one massive launch, simplifying logistics and reducing the number of critical mission steps. The idea was brute force. Skip the complex steps, just go straight to the moon. It was a bold vision, relying on sheer power and engineering might to overcome the immense challenges of space travel. The Nova would have been the most powerful rocket ever conceived, capable of lifting unprecedented payloads directly to the lunar surface. Nova would have sent a massive spacecraft directly to the lunar surface, making the mission simpler but demanding immense power. The scale of the rocket was staggering. Its engines would have generated more thrust than any before, and its size would have redefined what was possible in rocketry. The mission profile was ambitious, aiming to land astronauts and equipment in a single monumental leap. But Nova was never built. Saturn V was enough for Apollo, and funding dried up after the moon race. As priorities shifted and budgets tightened, the dream of Nova faded into history. The focus turned to making the most of existing technology, and the Nova project was quietly set aside. The Nova concept was shelved, but its core idea, using a single super heavy lift rocket to simplify missions, remains compelling. Even today, engineers and space enthusiasts look back at Nova's bold simplicity and wonder what might have been if it had flown. Today, as we face new challenges, Nova's direct approach offers inspiration. Modern projects like SpaceX's Starship echo the Nova philosophy: build big, keep it simple, and aim for the stars. The spirit of Nova lives on in every new attempt to reach beyond Earth. Sometimes, overwhelming power and simplicity can be the most reliable path. In a world of complex solutions, there's still value in the straightforward, audacious approach. Old ideas can spark new solutions. The Nova rocket may never have flown, but its legacy continues to shape the future of space exploration. Nova and Starship represent two radically different philosophies in rocket design. Brute force versus reusability. Both are titans of their eras, but their approaches to reaching the moon couldn't be more distinct. Nova was an expendable giant, engineered for a single, awe-inspiring launch. It relied on enormous clusters of powerful engines, all firing together to send a massive payload directly to the moon in one go. The idea was simple: build the biggest rocket possible, use it once and achieve a spectacular result. Starship, on the other hand, is all about reusability. Both its booster and upper stage are designed to return, land and fly again, dramatically slashing the cost of each mission. This philosophy aims to make space travel routine, not just a rare event. But reusability comes with trade-offs. Starship must carry extra hardware, like heat shields, landing legs, and additional fuel for the return trip. All this extra mass means it can't carry as much payload to deep space destinations as a single-use rocket like Nova could. That's why in-orbit refueling is absolutely essential for Starship's lunar and interplanetary missions. By topping up its tanks in space, Starship can overcome the limitations of reusability and still deliver heavy payloads far beyond Earth. Nova's largest designs would have dwarfed even Starship's super heavy booster. With the raw power to send more mass directly to the moon in a single launch, no refueling, no stops, just pure thrust and ambition. Starship, by contrast, relies on a series of launches and in-orbit refueling, a complex relay race instead of a single, all-or-nothing sprint. This approach allows for flexibility and repeated attempts, but requires precise coordination and new infrastructure in space. Nova was about one spectacular, expensive launch, a technological marvel that pushed the limits of its time. Starship is about making access to space routine and affordable, aiming for a future where launches are as common as commercial flights. Starship can lift up to 150 tons to low Earth orbit, an impressive feat, but Nova was designed to send that same mass, or even more, directly to the moon in a single, uninterrupted journey. The key difference? Nova bypassed all orbital stops, launching straight for the moon. Starship, meanwhile, must pause in Earth orbit, refuel, and then continue its journey, a more modular, but also more complex path. Ultimately, it's a choice between a single powerful leap and a series of careful, calculated steps, each approach reflecting the technology and vision of its time. What if SpaceX built a Nova-style Starship for direct lunar landings, no refueling needed? By stripping out reusability features like heat shields and landing legs, Starship could carry more fuel. This expendable version could launch fully loaded, fly to the moon and land all in one go. It would require a beefed-up super heavy booster, maybe with more engines or more thrust. The booster would still return to Earth, but the Starship would be a one-way trip. This approach trades reusability for simplicity, echoing Nova's brute force mission profile. It could be a practical shortcut for Artemis, buying time while refueling tech matures. A single-launch direct ascent Starship would slash mission complexity and risk. Instead of juggling multiple launches and dockings, NASA could focus on one big event, something they've mastered for decades. This could keep Artemis on schedule, sidestepping delays from unproven refueling tech. A direct ascent mission would be faster too, no waiting weeks for tanker launches and fuel transfers. Fewer launches mean less strain on resources and infrastructure. Even if the Starship lander is expended, the overall mission could be cheaper and more predictable. For NASA, a simpler path to the moon could be the key to building momentum and public support. It's a backup plan that could become the main plan, at least for the first landings. Sometimes the fastest way forward is the most direct. Even if direct ascent works for the moon, in-orbit refueling is vital for Mars and beyond. The fuel needed for a Mars mission is far beyond what any single rocket can carry from Earth. For deep space, assembling and fueling spacecraft in orbit is essential. Think of it like early explorers, small boats for coastal trips but big ships and resupply for crossing oceans. Direct ascent Starship is perfect for the coastal moon trip. But for Mars, we need to master fueling in space, our harbor for building interplanetary ships. Cryogenic fluid transfer in orbit is the key to a true spacefaring civilization. Fuel depots will enable routine, sustainable travel across the solar system. The shortcut to the moon is smart, but the long-term strategy depends on space refueling. Progress in space isn't always a straight line. Sometimes old ideas find new life. A Nova-inspired direct ascent Starship blends 1960s simplicity with modern tech. Flexibility and creative thinking drive real breakthroughs. If a single-launch Starship gets us to the moon faster and safer, it's worth pursuing. Both direct ascent and refueling are vital. One solves today's challenge, the other unlocks the future. Innovation often means connecting past wisdom with new tools. By embracing this mindset, we can overcome space's toughest hurdles. The journey to the moon and Mars will be built on both new rockets and timeless ideas.